Hey, is anybody there? Hello? Ooh, okay, we got some people in attendance. Ooh, it looks like the gang's all here then. Okay, so let's get started since we got the gang all here. Ooh, very strong attendance. Except, where's Waldo? Oh, Waldo was hiding behind Godzilla. So 6 questions today, one for each day of the week. No, 6 questions today, one for each planet of the solar system. Well, once upon a time, we thought there were 6 planets. One for each finger on your hand. Not too many of us are in that case. How about there are 6 questions today. Okay, 6 questions. And hopefully you've got the worksheet in front of you. I made photocopies Friday before I left the building and left them on my desk. So hopefully whichever guest teacher you have today has been able to find those worksheets and get them out to you. Please work through this. Some of you might want to answer all 6 questions and then check your answers. Some of you are like, nah, I want to do one at a time. Right, so this video does include the step-by-step solutions. Maybe you'll do all 6, which I kind of doubt, and then check, or you might do one at a time. And unfortunately, there's a reason why I'm chuckling. I thought question number 1 was pretty wicked, and so I decided to change question number 1, and I moved it to question number 4, and I put a more straightforward question number 1 on there, and I made photocopies. But when I got home, I obviously did not save the changes, so I am hoping you have a relatively straightforward question number 1, so your question number 1 will not match question number 1 on this video if I'm lucky. If I did not make the change, the worksheet in front of you looks identical to the one saved on my computer. And oh boy, question number 1 is a challenge. So if your question number 1 looks identical to question number 4, you have what I have on my laptop. I am hoping your question number 1 does not match question number 4. That means your question number 1 should be pretty straightforward. But if you're watching this as a class, you might decide to all look at the answer for number 1 together. I'm also got this available on Schoology, so if you're like, no, I want to work at my own rate, you can put on some earbuds, headphones, and work at your own rate and watch this video on Schoology. Without further ado, time for the worksheet. And some of our friends that didn't make it before, they're showing up now. Time for the worksheet. Oh, hey, Waldo was hiding in the milk canister. That was pretty funny. Now, if you're still watching the video and you've not done question number 1 yet, please stop. And again, I'm hoping your question number 1 is different from this. I hope it's a question that's pretty straightforward. So you might want to switch back and watch this after you've completed question number 4. But if this is what's on your worksheet, we'll go through it. Again, pause or stop if you need to, because I'm going to start discussing how to solve this one. Again, on your worksheet, this might look identical to number 4, or if I'm lucky, this is number 4 on your worksheet and not number 1. Well, what technique would we use on this? Yeah, boy, use substitution. Hey, yeah, integration by parts. What if we let u equal x squared and dv equal e to the 3x dx? du is easy. Du will be 2x dx. V is not too difficult either. If I integrate e to the 3x, I'll get e to the 3x. But I gotta think about chain rule and say, oh yeah, I gotta put a 1/3 out in front. Because when I take the derivative, the chain rule says, hey, you have to multiply by 3, but I don't see a 3 in front of that e, so I need that 1/3. So our integral, notice I've taken off the limits. I've taken off the 2 and 4. I'm just looking at the integral itself, and then we'll put the limits back in later. So the integral is equal to u times v, subtract the integral of v du. How am I going to integrate that? How am I going to, oh boy. Okay, well, first I did a little bit of rewriting. Right? That first term, the u times v, I just rewrote as a fraction, that 3 as the denominator. And then for the integral, the 2 from that 2x became part of the numerator. So I've got 2/3, and since that's just a coefficient, it can go in front of the integration symbol. And then I put the x in front of the e to the 3x. How do we integrate that? That's right, integration by parts again. U is equal to x. dv is equal to e to the 3x dx. So du is just dx. Once again, v will be 1/3 e to the 3x. So if I rewrite that, I've got the 2/3 as a coefficient, and then I've got to go u times v minus v du, and now I've got something I can actually integrate. And of course, there's a common denominator of 27. Right, 3 times 9 is 27, so I'm going to rewrite everything with a common denominator of 27. Alter all the numerators as necessary. And then we need to evaluate it at 4 and 2. Obviously, I'm a little bit short on space, and if I do that, I'll get 122 e to the 12th minus 26 e to the 6th over 27. And again, this question is pretty wicked, and I'm hoping it's only number 4 on your worksheet. And I'm hoping you had a more straightforward number 1 to start with, but you know, I'm making this video at home, and all I can do is look at what's saved on my laptop. Oh, shoot. There's square tunas, right? We also have to have our units if we're doing area, and the direction said that we're finding area. Oh, and one of those squire tunas is wearing her suit of armor. This is kind of like a rerun here. All right, we've seen the squire tunas before. They get out of the picture, squire tunas. So let's get all that work back up here. So there's all the work. Again, pause the video as needed, stop the video as needed, rewind the video as needed. Question number 2. And again, if you've not attempted this one, I highly recommend you pause or stop the video. At this point, I'm going to proceed. Secant squared of x. That's easy to integrate, right? That's just tangent of x. Right? The derivative of tangent x is secant squared x. Super easy integration. Substitute the values for x. Tangent of pi over 3, of course, is just root 3. Tangent of pi over 6 is just root 3 over 3. Common denominator would be 3. Right? 3/3 is equal to 1. So that 1 cube root of 3 becomes 3/3 cube root of 3. If I got 3 of those root 3s, subtract 1 of those root 3s, I end up with 2 of those root 3s. So the answer is 2 root 3 over 3. As runes quit. All right, here come those runes. And they quickly disappear. Those runes are just quitting on the job. And so we've got square units. So that takes care of question number 1 and question number 2. Again, pause, stop, rewind as needed. Question number 3, if you've not yet attempted this, please pause or stop the video and try to get the work done first, and then you can check. Okay, here we go. This looks like partial fractions, right? It's not a u substitution, because if I try a u substitution, du is not the numerator. So I'm thinking, hey, I know you get x times x. Negative times negative makes the positive on the 72. Negative and negative will add up to negative for that 18. 6 and 12 is obviously the magic pair of numbers. Negative 6 times negative 12 makes the positive 72. Negative 6 plus negative 12 makes the negative 18. Got to figure out the numerators. But I'm like, hey, somehow that 4x minus 42 has to show up. If we let x equal 6, b will disappear, right? Because 6 minus 6 is 0, so 0b, it's gone. So if x is 6, we can quickly deduce that a has to be 3. Now, if I let x equal 12, that will eliminate a from the equation, right? Because 12, take away 12 is 0. 0 times a, poof, the a is gone. So I want to plug in 12 for x. And I can quickly deduce that b equals 1. Right? So far, so good. 3 is a coefficient. Natural log of x minus 6. 1 is a coefficient. Don't really need it. Natural log of x minus 12. And, of course, I got to evaluate that at 10 and 9. Being the genius I am, I picked those two numbers. Oh, boy. Plug in 10. Plug in 9. And you should immediately see a problem if you didn't see it before. I've got a natural log of negative 2, right? 10 take away 12 is negative 2. I see a natural log of negative 3, right? 9 take away 12 is negative 3. So, yeah, if you got here and thought, hey, something's wrong, you're right. Right? They're undefined. I'm like, oh my goodness, I can't believe I did that. I can't believe I left you with a messed up number 3. Now, the good news with number 3 is you can still recognize it as partial fractions. You can still find the partial fractions. You can still do the integration. But then when you try to substitute the values, you realize, uh-oh, we've got a problem with the domain. So there is no solution. And then number 4, which is probably the wicked question on the page, I have a question number 4 that's identical to question number 1. And so if you've already done this as question number 1, go ahead and skip it. Again, I'm kind of kicking myself over this, but, well, it is what it is. So those 6 questions are turned out to be a little bit of a disappointment because I've only got 5 different questions on my version, and question number 3 did not work. Good news is questions 5 and 6 work quite well. Questions 5 and 6 are both rather straightforward. If you've not done question number 5 yet, please stop or pause the video. Okay, if you are here, let's start taking a look. What technique? What method? Looks like a U substitution. Real simple U substitution. U is x squared, so du dx is 2x. So du is 2x dx. Uh-oh. I need a 3x dx. Right? I see a 3x in front of the cosine. No problem. Multiply both sides by 3 halves. I now have a 3x dx. And so a 3 halves du will substitute for that 3x dx. Oh, I've changed variables. So if u equals x squared, well, if x has to be root pi over 2, and I square that, notice the whole fractions inside the square root symbol, right? It's the square root of the quantity pi over 2. Squaring undoes square root. Other one's a little bit more straightforward. 0 squared is just 0. So I can rewrite the integral. I still have 0 as the lower limit. The upper limit is now just pi over 2. And I have 3 halves cosine of u du. The 3 halves is a coefficient, so it's going to sit there. If we integrate cosine, we get sine, right? Because the derivative of sine of x gets us cosine of x. Or in this case, the derivative of sine of u would get us cosine of u. So if we go the opposite direction and integrate, the integral of cosine of u would become sine of u. Again, the 3 halves just sat there because it's a coefficient. Sine of pi over 2 is just 1. Sine of 0 is just 0. 1 minus 0 is just, of course, 1. 3 halves times 1 is just 3 halves. Are you it? Square units. One question to go. Again, same request. If you have not yet made an attempt at this question, please pause or stop the video. Resume the video when you are ready, either because you've solved the question, or maybe you got stuck and you just kind of need a hint to get started. Okay, I'm back. What to do, what to do, what to do. Is this going to be partial fractions? No, I don't know how on earth I'd be able to factor that denominator. Integration by parts? Thankfully not. It's just a u substitution. Let u equal the entire denominator. The u dx will be 15x squared. Is that magical? Look at the numerator on that fraction. 15x squared is exactly what we needed. So 15x squared dx will be traded out for a du. The denominator will just be u. Ooh, hey, we got some interesting limits. So I got to take that cube root of e plus 4 over 5, and then I have to cube it, multiply by 5, and add 4. Well, cubing undoes the cube root. Multiplying by 5 undoes the divided by 5. And I'm kicking myself because I bet I wanted a minus 4, right? E plus 4 minus 4 would just be E. That'd be really sweet. Instead, we got E plus 8. I'm like, oh, man. Oh, well, these things happen. We can still do the question. And then, of course, for the number 1, 1 to the third power is 1. 5 times 1 is 5. 5 plus 4 is 9. And again, I'm really thinking instead of 5 plus 4, I wanted 5 minus 4. But we can still do the question. All right, we go from 9 to e plus 8. 1 over u du. Integration at this point is real simple. That's just a natural log of u. but we got some crazy numbers to plug in. Right? I'm sure I designed it in my mind that we just plug in E and plug in a 1. But instead, we got to plug in E plus 8, and we got to plug in 9. And there's not much simplifying we can do, right? I mean, there's an answer. It's a legit answer. Yeah, squat ursine. That's a very squat-looking ursine. Right? Squat-looking bear. So the question was possible. It just didn't end up quite as neat and tidy as I thought it was going to be in my head. And the neat thing about this little squat ursine is, yeah, maybe you did, maybe you didn't use these, but they're quite often used in like kindergarten or first grade as counting devices, right? And sorting devices. And so the bears often will come in like different sizes, different colors, and there's a lot of grouping activities that you can do with young learners. And I just kind of find it neat that if you go into like a math supply store, whether it's a physical store or a website, you'll see these bears for sale. And I'm just thinking, hey, think about where you started when you first started with preschool or kindergarten. And it's like, hey, here's the counting bears. And look at the math you're doing now with calculus. I just kind of think it's been an amazing journey. Thanks. I will be back in the classroom tomorrow.